Hello and welcome to this video, where I'll be showing you how I made my 3D printed Iron Man glove and how you can make your own. Now, before we start, I'd like to quickly explain the concept of this video. Firstly, I'm going to show how the glove works, and then I'm going to explain the different steps to make it, starting from the 3D printed parts to the prep work in painting and ending with the electronics and code. For the 3D printed parts, I will provide links in the description where I found them, and for the electronics, they are entirely my own design, so I will provide the names of the parts and circuit diagrams, as well as the code that runs the glove. So, this is what the glove looks like when it's not on my hand. You have the fingers, which are all made with multiple joints, so they can actually flex quite a bit. And they are also put on with elastics, so they can move quite a bit. This part, this is kind of like the wrist part of the glove, can also move. And in order to put it on, you have elastics, elastics here and elastics here. And on the other side, you have some very powerful magnets. They are very small, but they actually work super well. You have 1, 2, and you have the corresponding 1, 2 here. You can actually see some of the electronics as well. And in order to close it, you just click it closed, and at this point, it's actually pretty solid. Like, you don't have to worry about it falling off if you're walking around or something like that. Maybe if you're gonna like punch someone or something, it might be problematic, but for just walking around, absolutely no problem. And right now it's in a sort of demo mode where the light is always on, and this is great for if you're just walking around or showing the hand to people and you don't want to trigger a bunch of effects when you're not ready for it. But if you want the sound effects on, you have to turn off that mode, and this is slightly weird, but you do that by knocking on the side of the glove, and it detects the vibrations and it turns off demo mode. And now it will react depending on how you position your hand. So if you position your hand like this, it will turn on a sort of charge up sound, and this is for example, you know, in the first Iron Man movie, when he kind of charges up his glove and then kind of decides to not shoot. So if you do it like this, it will turn on and then go back again. And then if you want to fire, you just point the palm forward and it will react to that. So if you're just walking around, all you need to do to fire, if I try to hold it roughly how it would be on my hand, is to point the hand forward. And obviously now it's going to react if I hold the palm backwards. So normally while walking around, that's not really going to be a problem, because you're going to have the hand either like this or maybe downwards. You're not really going to be walking around the palm up. But for just showing it off, you might want to, have the normal the demo mode on, so you don't have to worry about that. Battery is right here, connector is right there, and if we open it up a bit more, you can see we have all the electronics inside. This little part is the accelerometer, so it keeps track of where the hand is pointing. This is the, let's see if we can, the microcontroller. Over here is the speaker, and also very far inside, I don't think I can get it on video, but is a little speaker amplifier. Then in the middle you have the LED ring, that controls all, or like that emits all the light. So when I originally started this project, I made a bunch of different 3D printed parts. So this was probably the first one I did. It's missing some of the prongs that go down here, and that's just because it came loose off the print bed, I believe. But this is 100% size, and it fits okay, but my first impressions were that it was a little bit too big. So I went back and I made one version that is, let's see here, 90% size. And that one actually works great for my hand, just like this. The problem was that when I went to put all the electronics inside, I realized there was just no way my hand was going to fit inside this with all the electronics. So I ended up having to go back and make one in 100% size. So that's something you're going to need to be aware of. Sizing isn't just based on your hand. For example, this would fit my hand perfectly, in my opinion, but it doesn't fit with all the electronics. So you're going to need to make it a bit bigger than what you might expect. Also, the fingers are an absolute pain. Not only do they need to kind of fit together, but they also need to be individually scaled, so you're going to need to do each finger kind of one at a time and make sure that everything is the right length and they fit your fingers. So while you might be able to get away with just making one of these if you're lucky, chances are you're going to need to make multiple versions of the fingers until you get some that fits your fingers perfectly. In this project, all the parts were printed on my Ender 3 Pro with PLA and standard settings, a 0.4mm nozzle and 0.2mm layer height. Most parts did not have a flat side, so they were printed standing up with a brim underneath, which required the least amount of supports. The fingers were printed with the flat side down. You will need supports for most parts. Filament color really shouldn't matter, except for the white centerpiece of the glove, which needs to be white, or perhaps clear PLA might work too. In order to prepare the parts for painting, I first filled in any big gaps with this, which is a sort of paste, which once dried can be sanded down flush with the rest of the parts. I sanded all parts with sandpaper, from 180 grit up to 600 grit. After this, I coated all the parts with a thick layer of filler primer. This filler primer is a Swedish brand, but any filler primer should work. After this, I sanded the pieces again, from 400 grit up to 1200 grit with wet sandpaper. Doing this revealed a lot of the original part's surface underneath the primer. But this is okay. My philosophy is that the primer will fill in any low points of the part, and sanding will get rid of any high points. So after you apply a second coat of filler primer, you should be left with a smooth surface. After this, I painted all the parts except for the center white piece with 3 coats of duplicolor red, waiting about 5 to 10 minutes between coats. After waiting 5 minutes after the last coat of color, I applied 2 layers of clear coat to all pieces, including the white centerpiece, and let it dry. With spray paint, it's very important to make sure you apply multiple thin coats instead of one thick coat, so you don't end up with any runs. If you do get runs, sand the paint down and try again. For the electronics, I use an Adafruit Itsy Bitsy M4 Express as the controller. I chose this for 3 reasons. The controller is small, has onboard storage for files, and has specific pins that can control NeoPixel type LEDs and output sound signals. The V-High pin on the Itsy Bitsy M4 Express provides 5V power to the LEDs, and the D5 pin runs on 5V logic, which is needed to control the LEDs, despite the board actually running on 3.3V logic. The A0 and A1 pins provide DAC signals for sound to the amplifier. The Itsy Bitsy M4 Express is powered by a lipoly backpack that provides power via a battery. The LED in the middle is a WS2812 RGB ring. It came with 4 rings, but I'm only using the inner 2, because those are the only ones that could fit in the glove. The accelerometer that controls when the glove makes noises and shines its light is a LIS 3D-H triple axis accelerometer, connected via the SEL and SDA pins. And to play sound I use a PAM8302 2.5 watt mono amplifier, which delivers sound through a miniature speaker inside the glove. The battery is a simple small quadrocopter battery. The biggest difficulty with this project is making sure all the electronics fit inside the glove, while also leaving enough space for my hand. In this picture you can see how all the electronics fit inside the glove, with the accelerometer on the right, the microcontroller in the middle, and the speaker and amplifier to the left. You also had the ring LED light in the middle. This is how the electronics are connected. Depending on what kind of diagram you find easier to read, I have 2 different ones. Now in reality I'm not using 2 LED ring lights, but the way my LED ring light works is that you have to connect the outer ring to the inner ring. So you connect your microcontroller to the outer ring, and then you have an output for the controlling signal on the outer ring that goes to the input for the controller signal on the inner ring. So in order to simulate that, I'm using 2 different LED lights in these schematics. Now the code I'm only going to explain briefly, but if you want to see more detail you can check it out on GitHub. The glove runs on CircuitPython, which means most of it is written exactly like normal Python. The microcontroller reads the values from the accelerometer and uses those to decide what to do. Depending on how you hold the glove, it will trigger sounds and lights. The lights are set to slowly ramp up, instead of just turning on straight away, to increase realism. The sound files are stored on the microcontroller directly. The accelerometer can also detect taps, which is how you turn on and off the demo mode. That was all for now. Thank you for watching, and I wish you the best of luck with making your own Iron Man glove.